so that's sweet. Okay. So we're basically going to work backwards from this spectrum to figure out which of these answer choices is the molecule we are looking at. So I'm sorry for zooming in and out so much, but I am going to make this bigger so we can see it a little better. So my order of doing things can change a little bit depending on the spectrum they give us, but usually the first thing I look at is chemical shift.
What about looking at the index of hydrogen deficiency too? Because I use that for some of these problems, so you can rule out like certain ones.
Yeah,
Uh,
I think that's a really good method. I just wouldn't look at that as my number one thing.
oh yeah,
Yeah,
no, for sure. I
I
just
do the same thing. Like it rules out double bonds and rings, right?
it
Yeah,
will rule out which ones, yeah, it'll rule out which ones like if you have too many or too little um index of hydrogen deficiency.
mm-hmm. So yeah, if that, I'm gonna show you how, like the order I tend to do it in, and then if it works better for you to do that one first or like second or whatever earlier on, by all means do it. It's whatever is fastest for you. Okay, cool. So what I mean by chemical shift is I just quickly go in and like um, cut up the regions, right? So this one pretty much goes up to 12, so all the regions are present. What's our first chemical shift region?
The first one's like the alkyls, or I forget the other
Yes.
word.
Alkyl or aliphatic. So where does that one end?
That one's 1 to 2, isn't it?
2.5, yeah. So all of this, I'm not going to do that actually. All of this is alkyl. And then between 3 to 5, we don't really care about, but that's the heteroatom region. 5 to 7 is the what region?
Double bond.
Double bond, exactly. So I'm not going to draw them in, but we know 3 to 7 is hetero and double bond. And since this region is empty, we don't have either of those things in our answer. Next, we have the like 7.5 to, could you work, to around 8.59-ish. And what is this region?
The rings, the hydrogen rings on rings.
Yeah,
Aromatic rings.
exactly. And then past 9 is going to be the what region?
Carbonyl groups.
Yes. So I'm going to test you a little bit. If it's closer to 9, what functional group is it?
Aldehyde.
Heck yeah. And if it's closer to 12, what is it?
Carboxylic acid.
Awesome. So this one right here, is it going to be an aldehyde or a carboxylic acid, most likely?
Carboxylic acid.
Hell yeah. Okay. So far, all right, if you're going to be like that, that's fine. So far, we have determined that we don't have any double bonds or heteroatoms. We also determined that we have a carboxylic acid most likely, and we know we have some aromatic stuff going on and we have some alkyl stuff going on. So one thing you might be thinking is, what the heck, Rosemary? We have double bonds and oxygens here, but why is that different than this region?
Sorry, could you repeat what you said?
Yes, of course. So here we have our double bond to the oxygen, and we have this oxygen, oxygen, oxygen. So how come that doesn't count in the double bond or heteroatom region? It's a weird question, but
Doesn't have it doesn't have it.
well,
I
it
don't know if that
does because it has double bonds, right? All of these answer choices have double bonds and they have oxygens.
yeah,
Because
but
there
not
isn't, because I know the heteroatom region, it's
it
something
doesn't.
without hydrogen or carbon connected to it.
That's what I was trying to say. That's what I was sorry. Like basically we don't have that particular arrangement in the molecule.
Exactly. And okay, so the big thing I wanted to get to is this one technically follows that, but double bond region is strictly carbon to carbon double bonds. So anything that is an oxygen present is not going to count. Plus, a carbonyl won't be in the heteroatom region. If it's double bonded to a carbon, it'll be in the carbonyl region. A lot of people get tripped up on that. You guys seem to be pretty good, but I did want to point that out. Yes, I will definitely say that again. So a carbonyl is basically a carbon double bonded to an oxygen. And so if we have an oxygen present in the carbonyl structure, this automatically goes to the carbonyl region. So even though we have heteroatoms and a double bond, it doesn't count in this region. It goes here. The other thing is, in an aromatic ring, yes, technically we have double bonds. However, they're all in the aromatic ring, so it's only going to show up in the aromatic region, not the double bond region. So it's better to look things, I guess, as a unit instead of each piece individually. And I know that's different than IR because in IR you looked at all the pieces. All right, so that being said, which one of these guys can we automatically kick out?
Well, definitely the fourth one because it has a double bond to the oxygen.
1, 2, 3, 4. Well, here, let me also draw this for you guys out. So a COOH, what functional group is that?
Carboxylic acid.
Yes. And a CHO is what?
That's aldehyde.
Yes. Could you go away any faster? That'd be awesome. All right. Aldehyde. You already told me. Carboxylic acid. And carboxylic acid. So sometimes he will do this to trick you. So you guys have to know some of the abbreviations. And I don't mean to pick on you. Everyone makes this mistake. That's why I pointed out. So now that it's drawn this way, what do you guys think? Which one can we automatically take out? And
Can't we get rid of the aldehyde one?
I'll say A, B, C, D, E. Yes, we absolutely can. So we can get rid of B. I don't know why it's doing that. We can get rid of B because
Plus the integration part doesn't match, right? It just says, does it just say, or no, wait, what? I can't see the top part of it. The chart.
we
Oh no,
can
it says one. Okay, so integration does match.
it does.
Oh,
But even just by only the chemical shift region, we know it's wrong, right? But if you did want to double check, the real issue would come from here. So the aldehyde is definitely correct, but what do we see here? What functional group is this?
heteroatom. Yeah, the heteroatom. So
Exactly.
what?
So it's also wrong because of the heteroatom. And that's a really, really big one. All right. Are there any other ones that we are like, ew, that's automatically disgusting, we hate it. Okay, cool.
A, because of the alkyl groups, like there's 3 signals on the chemical shift, and then there's 4. If you look at that CH stretch there, there's 4 of them.
Yes, you're absolutely right, but we're going to put a pin in that for 1 second just because I want to show you guys one more trick. So a lot of students, based on what I said, would also get rid of this one because this is not a carboxylic acid, right? But does anyone remember what functional group this is, what we call this?
That what is that? The S
Ester.
Ester. I
Ester,
was gonna
ester.
forget.
So yes, you're absolutely correct. So an ester is going to be almost exactly the same as a carboxylic acid when we think about chemical shift, right? So it's going to be in this area, right?
But the hydrogen part would, or the carbon part? Like, I don't understand that.
Okay, good. Oopsie. Could you calm down? Jeez. So that's a great point. Why would there be a difference between the carbon versus the hydrogen NMR? What do you think?
The carbon's directly, like, has attached to the double bond and the oxygen on either
Yes.
side and there. So the carbon would, but not the hydrogen.
Sweet. So yes, this will be in the carbonyl. I mean, yeah, in the carbonyl region, close to carboxylic acid. So how come this hydrogen wouldn't be in there? What do you think?
Wait a second, that one's, is that because of how it's got like the oxygen and then the carbonyl after it or whatever? Like there's more pull? Would that one still be in the alkyl region though, those hydrogens?
Okay,
Or like
um why do you say the alkyl region?
no, I was asking. I'm
Oh,
assuming it
okay.
would be here because it's got the oxygen and then the carbonyl after it. So there would be like a bigger pull. They would be more up downfield. Is it downfield?
Yes, they would definitely
Downfield.
be more downfield. So it's not going to be in the alkyl region because it's attached to a carbon that's attached to an oxygen, right? So definitely
Okay, so
not the
then that one
alkyl.
would be the oh, so that one would probably be the higher end of what the hetero region maybe?
Yes. So what we are going to say is this hydrogen and this hydrogen, first of all, are going to be super different, right? So this one would be in the alkyl region. And this one is actually going to be in the heteroatom region, but it's going to be on the upper end of the heteroatom region. So heteroatom is like between 3 to 5, so this one is going to be around 5. So I know it's a little bit confusing, but remember, if it's directly attached to a carbon that's directly attached to an oxygen, it will be heteroatom. Like you said, this extra pull is definitely going to have an effect. So it's going to be more deshielded than like a regular old heteroatom, but it will still be in that region.
Okay, so then we can get rid of that one too then.
Yes.
The ester. Okay.
Awesome. I know that was really long-winded and I apologize, but we can get rid of it because it is an ester. Exactly. The other, I'm so sorry, I lost my train of thought. The other part of it is there is no hydrogen here, right? So based on the integration, that would also be wrong because it wouldn't be 1, it would be 0. Okay. I feel like that was really long-winded.
Sarah, which part would be 0? Which part are you talking about would be 0?
So in this region, right, let's say we thought this was, in the carbonyl region. This actually doesn't have hydrogen, right?
Oh,
this,
yeah.
This carbon has no hydrogen, so we would not have an integration of 1.
Oh, gotcha. Okay, I thought I missed something. Okay, I see what you're
Nope,
saying.
you're good. Okay, cool. All right, so now that we're done with that one, we're stuck between 3 answers, and the next thing I always do is number of signals. So as someone mentioned, I believe it was Jordan, but I could be wrong, he said that automatically we see 3 signals in the alkyl region, and that's the easiest one to pick off first, right? Because A has 1, 2, 3. Could you work, please? That'd be so magnificent. 1, 2, 3. 1, 2, 3. And we have an integration of 3, 2, and 2. Here we have 2, 2, 2, 3, 2, 2, 3, 2, 2. So we can automatically kick off A because instead of 3, 2, 2, the integration is wrong. It's 2, 2, 2. Did I lose anyone with that, or is it okay? Good? Okay, awesome. So now we're stuck between C and E, right? And the next thing I would personally look at is, if you go in, it's really hard to see the splitting, right? So basically what I would do is pay attention to the aromatic ring. So this is where I tend to lose people. You guys have been pretty good so far, so I hope I don't confuse you. But essentially, we talked the other day in SI about how every hydrogen here with no substituents would be exactly the same, right? So if I have 1 methyl, we can draw a line of symmetry down the middle. If we have 2 methyls, we can draw a different line of symmetry. And so we know how to number the signals based on that. In these kind of spectra, sometimes it won't look ideal. So sometimes if you have, let's say, this molecule, we cut it down the middle. How many signals do we have, theoretically? Hydrogen signals.
3.
3, exactly. So 1, 2, 3. Sometimes on an NMR, it might look like 1 big signal or 2 big signal instead of 3. So if you were to ever give me something like this and say count the signals, 3 would be the correct answer. But if he gives you a spectrum and you just see 1 really big peak in the aromatic region, it might count for all of these. So don't get super freaked out if everything else in your answer matches, but then the aromatic region looks a little bit weird. Is that super confusing to anyone, or are we okay? No? We're good? Yes.
No, wait, like, what exactly do you want us to do when we come across a question like that?
So, okay, for example, let me show you one here that's really, really ugly. This is annoying. Okay, Okay, well, I can't find an example here, but there was one in like the homework or something at one point. Um, Basically, I want you to look at everything else and see if everything else matches up. All of these questions will definitely not be so difficult to answer that you have to like look at the aromatic region. 99% of the time, you can get rid of most of the answer choices just by doing the two things we've done so far, right? And so if you can't, then there's probably an issue with the question. Like if you're looking at it and you're like, the only thing that would separate the answer choices is the aromatic region, and the aromatic region is like illegible, then there's an issue with the question. Does that sort of make sense? I feel like that's not a great answer, but that's the best I got. Are we okay-ish? Let me know if we're not. Also, my laptop is about to die, so I'm just going to plug it in. Okay, was the not really like, it doesn't really make sense? Sorry. Charger is good as well. Okay. We're good. So let me send you the link. Someone asked about where you can watch the video. I will just send you the link right now to clear up any confusion. If you sent anything in the chat, I can't see it this very moment. I will look in 1 second. I don't know if you guys can tell, but I just crashed so hard. And I just like, my brain left. I feel like you definitely.
I don't know if we'll have time. I know we got like 15 minutes left, but also can you, in the meantime, what's today, Wednesday?
Mhm.
So can you give us just a night, because I know that this will be the last tutoring for you this week.
Mhm.
What for chapter 11 to focus on?
Yes.
Would you say like the solubility stuff and the
Okay, so let me just clear up something I said before I like give anyone, like make anyone freak out. All right. So basically what I was just trying to say is that sometimes the spectrum might look ugly and it might not look ideal, but that's going to be something more so in class or in the homework or in the textbook. On your exam, you're not going to get something that doesn't match. So I'm so sorry if I freaked you out. On the exam, it should be clear. If you cannot read the spectrum or something on the exam, there's an issue. You're not expected to like answer something you can't read or you can't like figure out. So again, I'm so sorry if I freaked you out, but the spectrum is always going to match the answer on your exam. In lab or in some examples he shows in class or in homework, sometimes it might be a little bit messy, but I'm not even going to worry about that right now because I feel like I freaked people out. How do you feel about that now? A little bit better?
I get what you're saying. You're just trying to test us, like to give us a harder question so we can have all the possible outcomes that we could expect in the test, but not
Exactly.
necessarily are going to be on the test.
Exactly. Cool. All right. Yeah, and I usually try to like give you guys a heads up about it, but that was not a good way of introducing it. All right, and then so what you said about chapter 11, I have an idea. So I will be sending you guys this much later in the semester because it's kind of a final exam thing, but I made this what to study guide. So I will just show you that. Okay, so this is basically all the concepts in chapter 11. You can take a screenshot or whatever. I'm not going to send you the whole thing because that'll just confuse you, but I am going to mark what you guys need to know for this exam. Again, I am going to try to set up a meeting with Dr. West so I know like exactly what you need and don't need. But from my past experience, this is important, know how to name. This is important, know melting point, boiling point, whatever. Know protecting groups. And I don't think ethers and epoxides will be on it, but I will briefly cover how to name crown ethers because that's a really easy thing. For these ones, these are Orgo 1 review stuff, and so I will put like an extra handout that's just like Orgo 1 review for those concepts. Don't spend too much time stressing over it. He usually has like 1 or 2 questions about that. So if you review the handout that I will send you for Orgo 1 review, you should be good. I know this feels like a lot, but once you actually go into it, it's not too many concepts. It shouldn't be too crazy. And if you don't want to wait until I cover it in the review, I would suggest watching the concept videos in the YouTube channel because those are going to be helpful. Like if you have questions or anything, we're going to cover it. But yeah, it might be better to just get some kind of exposure to it. Plus, Katrina's amazing. And I don't know if there's anyone else tutoring for Orgo 2, but Katrina's the best. So if you have time, go to her sessions as well. All right.
Can you, or I don't know if are we still doing, can we have a copy of this too with the link of the notes?
I'm here. I will take like a screenshot of sorts. Stop it. Sorry, I don't know what it's doing. All right, so I'll put like a version of this in what we were just doing, but I don't want to send you the whole thing because that'll just be confusing. So
yeah, no, that's if we put it all together, that's fine with me.
Yeah, and it should be easier to read. So here, let's just get rid of that because you don't know what this means yet. Delete.
Do you also have something like this for chapter 9 as well?
Yes, actually, I should. Here, let me. Bam. Actually, I'll keep this here just in case because these are all the concepts you're ever going to need to know for chapter 11. So I might as well keep that. And all the red ones are what you need to know for this exam. So let's go into this. For chapter 9, all right. I will just copy this because you basically need to know all of this. So, could you chill? That'd be so cool. Sorry, this whole online thing is so odd to me. Like, that you guys have to sit and watch me just move things around. I know it would be kind of the same if you were watching me write on a whiteboard, but it just feels weird. Could you chill? and I will send this to you guys. The only thing we didn't cover today is these two things. So we're technically at time, but it'll take like 3 minutes to cover. So we can cover it if you guys want to. If not, we can cover it. We can call it a day and cover it another time. Up to you.
I'm down to stay.
Yeah, same.
All
Wait,
right.
what chapter is that?
Chapter 9. So this is just a little bit more mass spec. So
I have a quick question.
yeah, what's up?
So, for this exam, it's gonna be 9, 11, 9, chapter 9, 11, and 12, right?
So I thought it was 9 and 11. Has he told you it's also going to include 12?
No, I think he just said it was gonna be 9 and 11.
Okay, that's what
Sent
I
us
thought.
an announcement. I think, I'm gonna try to look at it real quick while you're doing that. I think he sent us a Canvas announcement yesterday.
Yeah, he did.
Oh, he did? Okay, I haven't seen that yet. Would one of you
I can't remember what it says though. Yeah, I can't remember. I'll look at it right now.
Okay.
It
So,
says he said it covers MS and the chemistry of alcohols, naming, properties, information.
Oh, okay. Would you do me a favor and send me like a screenshot of that message? Because I don't think I
Yeah.
have seen it. And that would be super helpful.
What's confusing to me about that message though is that if it just covers mass spec, are we like completely ignoring NMR and that stuff? Because I'm guessing that that's going to be on there too.
No, yeah. NMR is definitely going to be on it. Actually, can you share your screen? Does it allow you guys to do that?
Yeah, I can share mine.
Okay, here. Let me stop sharing. And I will just also